Postulates practice, number 1A. So we are using always, sometimes, or never to complete the statement. We know that always kind of means true. If that statement is true all the time, every time, we put always. Never means the statement is just plain false. There's nothing good about the statement. And then sometimes means, the statement could go either way. I could find a time when it's not true, and I could find a time when it's true. So, 1A, two intersecting lines are blank coplanar. Here's the deal. Lines can be, here's their choices, intersecting, they can be parallel, and they can be skew. That's skew right there. Okay. Now, if they are parallel, they have 0 points in common. If they're skew, they have 0 points in common. So if two lines intersect, they have a point in common. If they have a point in common, it means they are coplanar. They are in the same plane. So as soon as they intersect, it means they have something in common. And when they have something in common, then that means that they are coplanar. Okay? Because these parallel, nothing in common. And skew, nothing in common. Okay. So two intersecting lines are always coplanar. 1B. Three intersecting lines are always, sometimes, or never coplanar. Well, that changes things a bit. I could have my two lines like this. Yep, these are coplanar. I could put a plane through it, but then I could take my third one. It changes when there's three, and I could do this. See what's happening? Can I put a flat surface through all three of my skewers? No, couldn't put a flat surface. Now, could I put a flat surface through them now? How I did, I laid them flat. I could. So sometimes I could, but as soon as I go boop and do this, as soon as I go from here to here, I have made them non-coplanar. That was a weird F. Sorry about that. 1F. 4 points are always, sometimes, or never coplanar. One thing I want you to walk away from yesterday with is that 3 points are always coplanar. Any 3 points are coplanar. Any 2 points are collinear. Any 3 points are coplanar. But if you throw a fourth point in there, I could put 3 points in one plane. There they go. My 3 points are in my hand. I have 3 M&Ms. And then I could hold one up in the air. That fourth point is non-coplanar with the other 3 in my hand. So 4 points are only sometimes coplanar. If that said 3, you would say always. But 4, you don't know where that fourth point is, kind of. Okay. All right. 2C. A, B, C, and F are coplanar. A, B, C, and F. Take a look at ABC. I want you, when it asks you something like this, I want you to look at the first 3. 3 points are always coplanar. Now, what plane are those points in? Because they have to be coplanar. 3 points are coplanar. All right. Those 3 points are in this flat surface right here. I'll call it cursive M. There it is. Those 3 points are in plane M. That is defined. That is set. It's locked in. Now, F is above them in a completely different plane. So, it is false that A, B, C, and F are coplanar. Now, I want to contrast that with D. Look at D. I'm going to do a D in green. B, C, D, and E are coplanar. So what I told you to do is look at the first 3 points. Do B, C, and D, do those lock us into a plane? And your answer should be no. Because B, C, and D are collinear. Take a look. When they're collinear, my plane could rotate. My plane can do whatever it wants to because those are collinear. If you take a tripod and you put its legs in a row, that tripod falls over. That tripod does not define a plane anymore. It's not stable. Those 3 points, B, C, and D, do not define plane M. There could be all sorts of planes that go through those 3 points because they're collinear. So the moral of the story is, I could put a plane through those 3 points and I could grab E. See, I could make my plane flat. There's plane M. But now I could rotate it. I still have my 3 points and I could go and grab E from up there because these are in a row. There, I did it. I just drew a new plane. I have all 4 of my points and I didn't have to bend or anything. So that's why D is so different from C. These were not collinear. These are collinear. Okay, 2G. That was a typo on the answers. We wanted to change this to a different letter, but we forgot to. So that should have been true. So change that if you got that right for real. Okay, last one that you asked about is 3B. Use the figure at the right to name the following 2 lines that are skewed to line EJ. Now, did I write all the possible answers on the answer document? No, I didn't, because there's a lot of possible answers. We want to find lines that will never intersect my blue line, but we can't write down ones that are parallel. So actually, let me do in red all the ones that are not eligible. Don't pick it, don't pick it, don't pick it, don't pick it. Don't name any of those. Those wouldn't be skew. We can't pick anything that's going to hit JE. So we can't pick CJ or FJ. We need to pick something. I'll do green for the right answer. We need to pick something that for all of eternity is never going to hit the blue line, but it needs to be going in a different direction. So CD would work, LH would work, GD would work, BH would work, AB would work, FG would work. Those are all good ones. Okay?